Welcome to our next episode of Breaking Bug Community Meetup. Today is anniversary meetup number 10. So it's a kind of achievement for all of us, for our team. And today's presenter, probably familiar for some of you, it's Aleksei Platkovskii, our lead test automation engineer, currently located in Izmir, in Turkey. And his topic for today is a shift left testing, how to cook it properly. But before I pass the floor to Aleksei, I have a kind of request. So, guys, if you are watching this video from YouTube, please subscribe on our channel, hit like or unlike button, and maybe left a comment. That is important for the YouTube and, of course, for us. That motivates us keep doing what we are doing. Thank you in advance. Okay, then. Aleksei, floor is yours.
Okay, thank you. And let's start our presentation. Before we will go further, I have a little disclaimer. It is not a complete guide for shift left testing because it's a very huge theme and topic. But today I will try to highlight the most important things from my experience and from what I saw on different projects. And let's start. A couple of words about me. I started working in IT sphere science 2007. It was a long time ago. Also, I started as MNLK and had 6 years of experience on such position. I have experience with performance testing about 3 years and actively automate different stuff from 2014. It means that I have a huge experience in different spheres on different projects, and I have some expertise that I want to share with you. Also, started from 2020, I'm a community driver. And before we start, I have a small background how I decided to talk about this topic. I have a colleague who started several months ago to work on a new project, and we discussed his new position and signed this discussion. We talk about typical testing practices and how they implemented on his new project. And I heard that developers on this project want that QA engineers started the testing activities on feature branches, not in domain. And we have some discussion about this topic. Is it a correct behavior or it's something unusual and maybe even ugly from QA processes perspective? And that's why I decided to take a look on left shift testing more in advance and share some thoughts with you. And what about we will be talking today? First of all, shift left and itself, its pluses and minuses, pros and cons. Also, how to cook it properly, what to do to implement such approach on your project. When you should shouldn't use this approach because it's not a silver bullet and it couldn't be implemented on every project. Sometimes it's better to use a standard approach. And also some typical points how to implement it step by step, not to ruin your process on your current project, or how to implement it from the scratch in the beginning of new project. Before we start talking about left shift testing, let's talk a little bit about software development lifecycle at all. It consists in from several stages. First of all, it is some requirement analysis or brainstorm. Second step, it is design, documentation, and prototypes. in different platforms. After that, we should develop these new features, for example, and only after that, in typical SDLC, we can make some quality assurance activities. And after all of that, deployment on the production stage, or etc. And as you see, we have a lot of different activities before, in theory, we should start our quality assurance. But quality assurance, it's not only about finding bugs, it's also about quality of all project. And we can start a little bit earlier our activity, not finding some bugs, but we can help our project to find some better ways to implement something or to avoid performance or security problems, even on not on the later stages, but in the earlier stages. Okay, what is shift-left testing? It is definitely, literally pushes testing to the left in our graphic of SDLC to get some earlier stages in the pipeline covered by some testing activities. The shift-left approach intends to identify and resolve bugs, problems, issues as early as possible in the development process. For example, we can start to test our activities from the scratch, from the beginning, during having brainstorms or feature discussions. And it calls testing requirements or testing documentation. Second point, we can start some testing activities during even testing code. Usually, only developers test their code during development with unit tests, some static analysis, etc. But we also can handle this activity as QA team and help them to find some bugs or problems before release. And typically, testing every build, it's our usual testing activity. We wouldn't talk about it a lot of too much today. As I said previously, shift-left testing, not silver bullet. I should be honest with you, and some pros and cons for it. The major pros of shift-left testing, it's early bug detection, and we know earlier we found our bug, it's cost us less to fix it. Second point is such approach helps us to improve quality of project at all, because continuous testing improves the overall quality of the software and leads to a more reliable product. Next point is it is about enhanced collaboration in the team. Such collaboration encourage better communication between developers, testers, business analysts, and etc., and other stakeholders from the outset, because the earlier you start to ask questions, the earlier you will find some bugs or problems and can help to fix them for your team. And also it leads to better communication between all of participants of SDLC process. Next point, it is cost efficiency. As I said previously, the earlier detection of defects significantly reduce the cost of associated with late stage fixes. The better way to fix bug, not to allow them appear on your project on production at all. And such approach often leads to faster time to market. It means that you will need, as a team, less activities to get a stable product, and that's why you can faster deploy it to the project. But such approach also has some minuses, cons. First of all, it requires some culture shift for all the team. It means that some organizations, flows, processes may face resistance from teams members, because it's not a traditional way or workflow established for many of all. Also, it's increased such activity increased initial effort. It means that your team, especially QA part of team, requires some investment in training, in different tools. We will talk about which tools are commonly used for this activity further. But also it means that you need to change as a team some current processes. Also, such activity needs some specialized tools, skills, and infrastructure. It means that if you want to shift left your testing, in general, you will need additional virtual machines, stands, datasets, etc., etc. Not every project can handle this, can handle such costs rises. That's why it's sometimes it's minuses. And the last but not the least, risk of overemphasis on early testing. It means that if you shift left your testing processes on your project, very often it leads to reducing some testing activity on latest stages. For example, someone can think that if he tested something on his previous activities during branch testing, something like that, he can skip some testing procedures, activities, or test cases during testing yields on production or staging, and etc. And it's also a minus for such approach. Okay. First activities that can be started as left shift testing in any project. It is testing of requirements, as I said previously. And for such activity in Agile, we have several possibilities. First of all, it is 3 amigos. When QA, developer, and business analyst can conduct some meetings, better to conduct them on regular basis. For example, once a week or 2 times per sprint, different way. But what for we should conduct such activity as 3 amigos? It is a very good platform to ask questions for both for all 3 sides. What a new feature will do, how it will be implemented, what if it interacts with already implemented features or features in development, etc., etc. The more questions QA engineer will ask on such meeting, the better understanding of whole process will be for not for only QA, but for developer and business analyst also. And the second activity where also we can start to test some requirements, not test, but ask questions, it's also refinement sessions. Usually we have 1 refinement session for the sprint, but it's also a good platform to ask questions for better understanding of the product, for better understanding of the development. And also it allows whole team to check that this new feature can be not only implemented, but implemented with proper quality, with full coverage of all cases, edge cases, and etc. Next point, where we can handle our left shift testing, it is testing new code. Usually we have testing pyramid on our project, and in most projects this area not a responsibility of QA engineers, but you should also, if you're a good quality engineer, to check that everything is set up on for such activities in good way. First of all, it's very recommended to use unit tests, and a lot of projects uses them. in proper way, but very often projects forget to use such instruments like static code analysis. Yes, for code parsing, compilations, etc. It's, I repeat, not a quality engineer area of responsibility, but if you see that something is missed here or has been done not in the best way, you can also try to help your teammates to improve this part of testing, because it also reduces your work. The better code you will get for testing, the less work you will need to do. Okay. And let's talk about testing activity when the feature was developed. We have two approaches here. First, it is testing on a main branch. It is typical behavior on a lot of projects, but I prefer to use testing in feature branches, not on the main. And I will tell you why. This is better for me, and maybe you will use it also on your project. First, let's talk about classes of such approach. Isolation. It means that any changes that were done during new feature development or refactoring or bug fixes should be isolated in a feature branch, and you can test them without any inheritance with other changes from other developers, teams, etc. They are isolated from the main code base, minimizing the risk of introducing bugs that are not related to your branch, your feature. Second point, it is parallel development. It means that if we develop several features in several teams or in one team, but by the efforts of different developers, you can test them independently, and everyone can develop their feature in multiple features or bug fixes and test it simultaneously without interfering with each other. In the main branch, if you merge two features or bug fixes simultaneously in the main and you start to test them, you wouldn't be, how to say, it's sometimes very difficult to define if you find some bug, which feature or bug fix leads to it. In feature branches, you can avoid such problems. Third point, it is focus testing. It means that when you know that only this bug or this new feature were developed in this feature branch, you can skip a lot of different test cases and just focus on the feature itself. And each development branch can have specific testing criteria, making it easier to focus on this feature, something like definition of done, definition of ready, and you can handle it without being affected by changes in other parts of the code. And also, it leads to flexibility in release management, because every time when you introduce some new feature, bug fixes, you, first of all, test them in the feature branch. It means that your main branch is all the time is stable. It has a minimal risk of different regression, bugs, and etc. But also, testing on the feature branch has some minuses. First of all, it is patch conflicts. While you're testing some branch, it can take sometimes a lot of efforts and time, for example, 1 or 2 days, and while you was testing this feature branch, something was merged in the main branch, and when your developer tries to resolve some conflicts and push these merge conflicts in a feature branch, you will need to restart your testing activity. It's not a good thing for sometimes. Also, it is integration challenges. It means that there might be challenges to integrate such approach testing activities with the rest of the system, especially if other changes have been made to the main branch before you, and they interfere with your new feature. one of the minuses also, it is resource intensive. As I said previously, you will need some additional virtual machines, some data sets, and etc. This approach requires more resource for branch management and also might necessitate additional continuous integration pipelines efforts to negate such drawbacks. And the last point of minuses is sometimes delayed feedback of integration testing and full system testing in such approach. Because when you focused on the feature branch testing, you test only feature, not whole the system. And sometimes it leads to delayed feedback for the integration testing. That leads potentially to delay in the discovery of integration issues for the whole project. Let's compare it with testing on the main branch. It also has some benefits. Immediate integration, it means that every feature will be delivered to the main branch after all code review processes is finished on the project. Next, it simplifies processes, reduces the complexity of managing multiple branches, manage conflicts, and etc. Also, one of the pluses of such approach is continuous testing, because team ensures that entire system is continuously tested, including new changes and regression testing activities. And in general, it leads to situation when every time when you test a new feature, you test the whole system. That leads to improvement of overall quality of the system. And faster feedback loop. Developers receive immediate feedback on their changes if they have some automated tests in pipeline during version activities. But also, such approach has some drawbacks. First of all, it is risk of stability, because very often you need that your main branch should be stable to be able to deploy it on production at any time. But introducing new features directly into the main branch can risk the stability of the code base. Potential blocking of different activities. If new features or bug fixes produces some errors and fails to pass even automation tests in your pipeline, it can block other development activities until such problems will be resolved. In a big teams, it leads to a lot of time waste sometimes. Also, such approach, testing on main branch, requires a very stable CI/CD pipeline to mitigate some risk. That means that you definitely should have some automated tests for some critical passes and critical functionality. And that requires some significant setup and maintenances and additional efforts. And the last minus, it is some feature toggles complexity, because to test everything on main, it's a bad idea, because if your project needs to deploy main branch on the production at any time, it means that untested features or tested not properly should be covered with some feature toggles to be able to prevent unfinished features from affecting the production environment. And feature toggles are often used on the teams, but it leads to some complexity and technical debt to the project at all. In general, I can recommend to use testing on the feature branches when you have a good code review and merge culture on your project. When your team has some proven technical skills, like working with Bash console, Docker, some Git commands, manual QA, because very often automation testers has all this have all these technical skills. And also when your team and your team task management is very good or even perfect, it allows you to develop in parallel branches, avoiding some interference. On the other hand, you also can use main branch testing. It's not left shift testing at all, but it also has some benefits. First of all, if you have perfect or very good CI/CD pipeline on your project, you can test on the main. Also, if your team not very big, a couple of developers and 1 or 2 testers, it's also maybe a very good idea to skip this problems with feature branch testing, and you can anytime test on the main because it wouldn't be changed very often. And also, if you have needs as a project to deploy your new features on the production as fast as possible, it's also a good idea to test on the main branch, to skip different activities after testing on the feature branch, like integration testing and etc. And also, if your project doesn't have enough efforts or resources to maintain additional servers, virtual machines, data settings, etc., it's also better to test on the main branch. Okay. How to implement it on your project if you have already installed some processes? First of all, I recommend start testing as early as possible. But when I say testing, it's not only about finding some bugs. It's also about asking questions for better understanding of the project, business area, functionals, and etc. Also, sometimes it could help your colleagues for better understanding what they're doing themselves. Automate as much as possible, starting from unit tests. If you don't have them on the project, you can ask your developers to cover main features with unit tests. You can talk about some even steps in pipeline to check test coverage, and etc. As a quality assurance engineer, if you're not automation engineer, just, for example, manual QA, you can start to test some features like API testing and simple UI testing with open source tools such as Postman. It also allows you to reduce some of your activities and test some features faster. Also provide fast feedback. Sometimes it's better to, after you create some ticket in the Jira with bug description, it's better to send this bug or link for it to developer in some direct message with Teams, Slack, etc. I often do this on the small projects because it allows developer to see what is not perfect in his feature branch and fix it faster, maybe even immediately. Collaborate with your colleagues closely, especially with developers and business analysts, because it's shift left testing works better when testers and the other part of the team work together closely. Regular pair with the developers to review user stories, to discuss testing strategies, even some coding before it begins. This helps ensure that code builds will be more stable and quality into the software from the will be approached from the start. Also, when issue comes to you, after you can work together to troubleshoot and determine the best solution to avoid such problems in the future. And don't hesitate to ask your questions, even if you think that it is simple and obvious. It's better to learn your project than to hesitate to ask something. And let's talk about some common myths and misconceptions about shift-left testing. First of all, very often you can hear that shift-left testing requires some specialized skills, but this isn't the case at all. Yes, you will need to learn some additional tools, but the actual testing activities are similar to traditional testing, and you don't need to highly technical skills to get this started. With some practice, anyone software team can pick up such activities. Also, sometimes I heard that shift-left testing takes too much time because, first of all, you're testing something in different activities like 3 amigos, refinement, you ask questions and it takes some time to get answers, or feature branches testing, and after that you need to test the whole system on the main anywhere. But on the contrary, I can say that shift-left testing saves times in the long run, because finding bugs and fixing them earlier is much more efficient than waiting until the final testing stages. Also, it may require more upfront planning of the team activities, but the time savings further down the line more than make up for it. Bugs found during shift-left testing aren't important. It's very silly point, but sometimes I heard also it. But all bugs matter when it comes to software quality and when it comes to our customer on the production. It means that shift-left testing aims to detect bugs as early as possible, regardless of their severity. Yes, minor issues detected earlier on would point to bigger problems that emerge later. And the best way is to address such problems and all bugs, no matter how small they seems to be. And also you can hear that shift-left testing requires major changes to processes, but I don't think that some additional meeting for 3 persons on the projects, even once per sprint 1 hour, leads to some big changes in the processes. But they can save you a lot of time during the development and testing at all. And while shift-left testing does involve some adjustment to workflow, the changes are minor in reality. Things like increased collaboration, short feedback loops, and focus on incremental development, it's good time savers and effort savers on long run. And shift-left testing complements agile methods many teams already use. Just add one more step. And in conclusion, I can say that the biggest pluses of such approach is catching bugs earlier, finding defects in requirements on design sessions or refinements, much more cost-effective than finding them in production. Improving quality of whole project, because by testing early and often, you can improve the overall quality of your project. Yes, it leads to more efforts, but quality is very important thing for the customer experience. And reducing rework, because detecting issues in early stages also minimize the amount of redesign and some bug fixes from your team. And faster feedback, because getting feedback from testers during even design sessions sometimes leads to even some feature changes in general. And it leads to less wasted efforts, because building the right product from the beginning avoids wasting time for wrong features or fixing problems on the later stages. And I think that's all from my side. Before we start our question and answer session, you can, as said Aleksei on greeting notes, that I have QR code for our channel. You can subscribe or just find our previous meetups here on these different topics. And that's all from my side. If you have any questions, let's discuss them.
Let me add a couple of points that could kind of add value to your meetup. So
sure.
Also, like in sprint automation could be considered as a part of shift left approach. And having common tech stack also helps to collaborate closely. I mean, developers and automation testers. It helps a lot to in troubleshooting also, and in like splitting work between teammates as well.
Yeah, good point. Thank you, Konstantin. And we have a question in our chat. Could you tell what tools we can use to implement shift left strategy in web app testing, given that Selenium and Playwright require a live backend, which goes against the concept? Additionally, Science Cypress component testing is a relative new tool. It has some compatibility issues in web app testing automation. Very interesting question. First of all, I'm not familiar with Playwright. I have not big experience with it, only a couple of months, but in Java and Selenium, you can use different mockups for such approaches. I don't remember by Playwright, but when I was using Puppeteer on one of the projects, we had very good tools for also mockups on that. 70% of our tests were written with mockups, not live datasets from backend, because also we was able to run them even on local machines. Probably you should Google for some tools that can mock up some backend answers, responses, etc. Okay, if we don't have any more questions, I think we can finish. Oh, we have one more question. In my project, there is no manual quality assurance engineers. Testing is done by developers through unit tests and manual test execution. I am the only automation engineer. The automation is not in sprint. How could I benefit from this approach? First of all, you can handle some activities during even design sessions when you can ask questions, and sometimes it leads to better understanding of project customer needs and some other things, even from the start. It means that when you're asking some questions and they are not covered in the document, it will be reworked. And it's also a plus for all participants, because developer can better understand, even developer can better understand after such questions what he and how he should implement new feature. Okay. Thank you, everyone. Okay, one more question. Colleagues, you can unmute, it will be faster, but okay. Any recommendations for the last stage UI testing and which is the better move left? Unit, API, component, some algorithm. We had a meetup about testing pyramid on the project, and the better way to shift left testing during UI testing and API testing, it's to implement a good testing pyramid. It means that, first of all, you need a huge amount of unit tests, but properly written, that are testing your functions, small functions properly, on proper way. Second way, it's to get some API testing. Next level, it is about component or integration tests, and only in the top of this pyramid, you should have some UI automation tests. And if you implement everything correct and put it in your CI/CD pipeline, it also will allow you to reduce some efforts for testing. Okay. Thank you very much, and hope you see you on our next meetups. See you. Bye.